All right, so homework day 9, we're going to simplify other radical expressions other than just plain square roots. They might be cube roots, they might be fifth roots, they might be fourth roots. So the first one is a cubed root. So if I have my list of perfect cubes, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64, 5 to the third power is 125, and that's probably high enough. If you needed to keep going, you could. But if I'm simplifying the cubed root of 32, the principle is kind of the same as the one with the square roots. We want the biggest perfect cube that divides evenly into 32. In this case, obviously 125 and 64 are too big. 27 doesn't divide into 32, but 8 does. So we're going to factor this into the cubed root of 8 times the cubed root of 4, because 8 times 4 is 32. We're then going to go ahead and take the cubed root of 8. The cubed root of 8 is going to be 2, because 2 cubed is 8. So again, like the square roots, this should be a perfect cube. It's going to come out and it's going to be a nice whole number, a plain old 2 in this case. This is going to go behind it, the cubed root of 4. So we get 2 times the cubed root of 4 for our answer in simplified form. Now when you're doing the fifth power, if I do 2 to the fifth power, we know that one is 32. I don't even know what 3 to the fifth is in my head because I use it so little. What's 3 to the fifth power? If you take your calculator and do 3 to the fifth power.
243.
243. See, they get big in a hurry, right? When you take it to the fifth power. So that's probably as long as I need my powers for fifths. So most of the time, if you're going to be able to simplify a fifth root, it's going to be because 32 divides into it, right? Because 32 is a perfect fifth power. So I'm going to say, okay, I've got the fifth root of 32 times the fifth root of 2, because 32 times 2 is 64. I'm then going to do my fifth root of 32, and my fifth root of 32 is 2. So there's going to be a plain old 2 in the front, that nice whole number 2, and then this is going to be go behind it, so fifth root of 2. So I get 2 times the fifth root of 2. Then the next one's doing the fourth powers. Fourth powers. 2 to the fourth power. 2 to the fourth power is 16, right? 3 to the fourth power. 3 to the fourth power is 81. 4 to the fourth power. 256. And again, we're getting kind of big, so that's probably long enough for that list. If you get bigger ones, you can always add to it. So when I'm looking at simplifying a perfect fourth power, is it divisible by any of these numbers? In this case, 48 is divisible by 16, right? So I'm going to say it's the fourth root of 16 times the fourth root of 3, because 16 times 3 is 48. And then I'm going to do the fourth root of 16. The fourth root of 16 is 2, again. So I'm going to have 2 times the fourth root of 3 for my answer. So most of the time when you're doing higher powers, because your numbers get big in such a hurry, 2s and 3s are about all you're ever going to be able to take out by the time you're done. The next one's back to simplifying square roots. So when we did our square roots, you wrote down the list of perfect squares, hopefully, somewhere handy. Because we're going to do the exact same thing we did before, only now we're going to add or subtract when we're done. With algebra or anything else, when you add and subtract, you have to have like terms. So if I have a square root of 5 plus a square root of 3, I can't add them because they're not like terms. I would have to have something like 5 square root of 5 plus 2 square root of 5, where they both have the exact same end part. So I'm going to simplify these just like I did before. If I have the square root of 75 to start with, I want to factor that. The biggest perfect square that divides into 75 is what number that's a perfect square divides evenly into 75?
I would say 5.
Okay, but 5 is not a perfect
25,
square.
I mean.
25. That's what I'd say, 25, exactly. So 75 is 25 times 3, right? Then we can do the square root of 25, which is 5, and I get 5 square root of 3. That one's simplified as much as we can simplify it. So now I'm going to do the minus 3 square root of 27. The minus 3 stays out in front, and I'm going to simplify the square root of 27. 27, what perfect square divides into 27?
9.
9. 9 times 3 is 27. The square root of 9 is 3. That's going to come out in front, and it's going to be multiplied by whatever is out there already. So now I have 3 times negative 3, which is negative 9.
Uh-oh.
And the board decided to go crazy on me. Negative 9 square root of 3 is what we had there, right? What was our other one? Our other one was 5 square root of 3, wasn't it? You have all the rest of the work up to there. So we have 5 square root of 3 minus 9 square root of 3, right? 5 minus 9, we think about like we would a 5x minus a 9x. We're just going to subtract those front numbers. 5 minus 9 is
4.
negative 4 square root of 3 then. Going to be our answer. So number 5 there, we have 2 square root of 45. I'm going to leave the 2 for now. I'm going to factor the square root of 45. Biggest perfect square that divides into 45.
Nine.
9, exactly. 9 times 5 is 45. The square root of 9 is 3. That's going to go out in front. We're going to multiply it by that 2 that's already out there. So 3 times 2 would give me 6 square root of 5 when I simplify that first term. Now I've got that plus square root of 20. 20 is not a perfect square. We can factor 20 into
4.
4 times 5, exactly. 4 is my perfect square. The square root of 4 is 2. So I get plus 2 square root of 5. And if I take 6 square root of 5 plus 2 square root of 5, I'm going to get
What'd you say? I was still waiting.
the 6 square root of 5 plus the 2 square root of 5.
You add them?
You add them together, you add the front numbers together, you get 8 square root of 5 then. So you think about it just the same way if I have 6x plus 2x, we get 8 x's, right? So the front numbers we add together, this is my label so that I have like terms. It's how many of those square root of 5s I have. So number 6, same kind of thing. This time I have negative 4 square root of 18. Oops, I better write the 4 in there. Negative 4 square root of 18. The 18, of course, isn't a perfect square again. We want to factor 18 into
Oh, 2. Oh no.
18 is
9.
9 times 2. So 9 times 2. We then take out the square root of 9, which is 3. We multiply it by what's in front, so now I'm going to get
Negative 12.
negative 12 square root of 2, right? Then I have that minus square root of 8. 8 is not a perfect square, but I can factor it. 4 times 2. The square root of 4 is 2, and so I'm going to have minus 2 square root of 2. Right, that minus sign is like a negative 1. Negative 1 times 2 is negative 2. So now I have negative 2 square root of 2 minus 2 square root of 2. They are like terms. Going to go ahead and combine those, and I would get
What, 14?
negative 14 square root of 2. Add and keep that sign, right? So those were the easier ones. Now they get into some crazy looking ones. We're doing the same thing. If we're going to add them, they have to end up being like terms, which means everything but the front numbers should match up. But we have to simplify them first. I have 4x square root of 27u cubed. So I'm going to have 4x, and I got to simplify that part under the square root. 27. I can factor that.
9.
9 times 3. So 9 times 3. I have a u to the third. Since it's odd, I want to change that to
A U minus, oh, U, yeah, and a U3.
and a u
2.
2. Right, it took out 1, so I got 2 left. U times u squared. Taking out my perfect squares. The square root of 9 is 3. The square root of u squared is
U.
u. So I have 3u times 4x, which would be 12ux. And then I have the square root of 3u left over, right? Now on that other one, we've got a minus u out in front, and then we got to simplify the square root of 75ux squared. 75 can be factored. 25 and 3. So 25 times 3. We can't do anything with the u, even though it's odd. There's nothing you can do with u, so we're going to leave the u. And then we have an x squared, which is already even, so we're going to leave the x squared. And then we're going to take out our square roots. So we can take out the square root of 25, which is 5. Whoops, I'm crossing out my 3 with my 5. Square root of x squared is
1.
just an x, right?
Just an X.
So 5x times negative u would be negative 5. I'm going to put them alphabetically, ux, because I want to see that they match up, and they do. And then underneath my radical, I still have a 3 and a u. Just like here under my radical, I have a 3 and a u. So everything should match up except for those front numbers. The front numbers then is what we're going to do. I have 12 minus 5. 12 minus 5 is 7. So my answer is going to be that I have 7ux square root of 3u. So number 8. We got the w squared in front. And then we got the square root of 8wy to the 4th. 8 is not a perfect square. Can we simplify 8?
Yep.
Yep.
4.
4 times 2. Again, we can't do anything with a plain w, and the y to the 4th is even, so we want to leave that as y to the 4th, so we can take out our square roots. Square root of 4 is 2. Square root of y to the 4th,
2.
y to the 2nd. So, doesn't matter if you write it as 2y squared, w squared, or vice versa. I'm going to put them alphabetically because that's how I like them. So I'm going to write it as 2w squared y squared, square root of 2w. If you switch your w's and your y's around, that's okay. You just want to know that they can be switched around. Now, on the second part, we've got a minus 4y squared out in front. Then we've got that 32w to the 5th. 32, the biggest perfect square that divides into 32.
Four. 16.
16. 16 is my better choice, otherwise I got a big long problem. Remember doing that one?
Okay.
So 16 times 2. My w to the 5th. That one has an odd exponent, so I need to fix that. What am I going to do?
W. Add another W.
W and w to the 4th. So I can take out my square roots. The square root of 16 is? The square root of 16 is?
4.
4. The square root of w to the 4th is?
W2.
W squared. So I have 4 times negative 4, which is negative 16. W squared, y squared, square root of 2w. Notice everything should match up after our leading numbers. We got a w squared, y squared, square root of 2w after both of them. Means I can subtract. 2 minus 16 is negative 14. So negative 14, w squared, y squared, square root of 2w. Going to be my answer. So the good thing about these ones is when you get to this last step, if they don't match up, you know there's a mistake somewhere and you got to go back and fix it. All right. Number 9. We've got a 6u, and then we got to simplify the square root of 18x to the 7th. So what should we do with the 18?
9 times 2.
9 times 2. What should we do with the x to the 7th?
X, and then another X. 6.
X times x to the 6th.
X.
So now when we take out our square roots, we can take out
9.
square root of 9 is 3.
X.
And we can take out the square root of x to the 6th, right?
Yep.
So we're going to take out x to the 3rd. So 3 times 6 is 18. Again, I'm going to put them alphabetically. So u x to the 3rd square root of 2x is what we get when we simplify that. Plus x squared is out in front. We need to simplify the 8x to the 3rd u squared. So 4 times 2 is 8. What else shall we do? X times x squared for our x to the 3rd. And leave the u squared because it has an even exponent. So taking out our perfect squares, we can take out. Square root of 4 is 2.
X squared.
Square root of x squared is an x, and the square root of u squared, u. So when we put those all together, we're going to get 2. There's a u. X times x squared is x to the third, right? And then I have 2x underneath my radical. So you'll notice after each of my leading coefficients, I've got a u x cubed square root of 2x. They match up all nice like they're supposed to. So I can go ahead and add 18 plus 2 is 20. U x to the third square root of 2x for my answer. All right. Now we're going to multiply. When we multiply radicals, we're going to start the same way that we did when we added them. We want to simplify each of them separately, just like we did before. So 2, and I got to simplify the square root of 32. 32 we factored into 16 times 2. Then we took out the square root of 16, which is 4, and multiplied that by the 2 in front. So we get 8 square root of 2 when we simplify that first term. Square root of 24. 24 can be factored into 4 times 6, exactly. 4 times 6. The square root of 4 is 2, so we get 2 square root of 6. Now this is the part that's a little different once we get to multiply. What we're going to do is we're going to multiply the front numbers together, we're going to multiply our square roots together. So we're going to do the 8 times the 2, and we're going to do the square root of 2 times the square root of 6. So 8 times 2 is 16. The square root of 2 times the square root of 6 would be the square root of 12. Now at this point, we may or may not be done. What we have to do is look at that square root and decide, can we simplify it further, or do we have to leave it like it is? 12 does have a factor that's a perfect square, so we can keep going to simplify this problem further. So we're going to do that. So if I have 16 square root of 12, 12 can be factored into our perfect square that goes into 12. Or 4 and 3, right? 4 is our perfect square. 4 times 3 is 12. Now if I tried 2 and 6, neither of those are perfect squares, so that's why that pair won't work. But 4 and 3, 4 is a perfect square. The square root of 4 is 2, so 16 times 2 is 32. Square root of 3, and now I have it where I can't go any farther with that 3 because it only has 1 times 3. So number 11, we got 45. What times what is 45? One of which being our perfect square, of course. Nine times 5, right? 9 is my perfect square. 9 times 5, the square root of 9 is 3, so I get 3 square root of 5. And I have 3 square root of 48. 48 we want to factor the biggest perfect square that goes into 48.
4?
There's a bigger one than 4.
16.
16. 16 times 3 is 48, right? So I want to use the 16 over the 4 because that's going to save me some work. So, square root of 16 is 4. 4 times that 3 in front would give me 12. Square root of 3. So now I want to multiply them together. I'm going to take the 3 times the 12, and I'm going to take the square root of 5 times the square root of 3. The 3 times the 12 is 36. The square root of 5 times the square root of 3 would be the square root of 15. Now I have to look at that and say, does 15 have any factors that are perfect squares?
Could.
Well, technically 1 is a factor, but 1's not on our list here. 16 is too big. 9 doesn't divide into 15, and 4 doesn't divide into 15. That means I'm stuck. I can't go any farther than that. This is going to be my answer. Unlike with the 12, where I could work it down further. 15, I'm stuck.
So you really don't look at the first number then either, right?
Nope,
Look at the
because
second.
that one's already done. You're just looking at the square root to see if you can simplify it. Number 12 then. We have 3 square root of 32. 32, what can we divide into 32? 16, right? 16 times 2 is 32. Square root of 16 is 4, so 4 times the 3 in front gives us 12, square root of 2. Square root of 18. 18 can be factored into 9 times 2. The square root of 9 is 3, so we get 3, square root of 2. So now when we multiply them, what are we going to do? Exactly. 12 times 3 is 36. Square root of 2 times the square root of 2 is the square root of 4. So we look at our square root. Can we simplify that?
Yeah.
Yep. 4 is a perfect square, right? We don't even have to do any factoring. We just have to do the square root of 4. When we do the square root of 4, what do we get? 2. We're going to multiply that 2 by the number in front, which gives us 72, and there's nothing left in that square root. So we just get a nice whole number on that one. So there's 3 different ways we saw that. One where we ended up with the whole number answer, one where we got the square root of 15 and couldn't simplify any farther, and one where we got the square root of 12 where we had to keep going because it could be simplified more even though we had multiplied it. Last 3, I think, if I remember right on this page. Yep. Simplifying the product of square roots again. Now in this case, you could try to simplify each of them separately and then multiply, but because my numbers aren't very big, it's probably easier just to multiply, then do my simplification. So it's really either way that you could do it. You just want to look and say, do I have really big numbers or do I have kind of small numbers that are easy to work with? In this case, I have kind of small numbers that are easy to work with. So I'm just going to go ahead and multiply them together first and make one big square root. So 2 times 6 is 12. X to the second times an X is an X to the third. U to the fourth times U squared, U to the sixth. Adding my exponents there, right? When I multiply, I add my exponents. So now I have that expression, 12 x cubed u to the sixth. I want to do the square root of that, so now I'm going to do my simplification and try to factor those things out. 12 is not a perfect square, so I'm going to factor that into 4 and 3. X cubed is not a perfect square because it has an odd exponent, so I'm going to factor that in too.
X times x cubed.
X times x to the second. And then the u to the sixth is a perfect square, so we're going to leave that one alone so that we can take out our square roots. So the square root of 4 is 2. The square root of x squared is an x. Square root of u to the sixth, u to the third. And then I have a 3 and an x underneath. So 2xu cubed square root of 3x is my answer. So number 14, we want to multiply those two square roots together. We're going to go ahead and multiply first. And so if I multiply those together, what am I going to get? 36.
Do you add those?
Yes, I do. So y to the 10th and w to the 10th, right? Now, when I look at that one, what do you know about 36?
Ooh, that could be brought out.
36 is already a perfect square, right? I don't need to factor it because it's already a perfect square. Same thing with the y to the 10th and the w to the 10th. Those are perfect squares because their exponents are both even. That means this is a perfect square. I'm just going to do the square root of everything. The square root of 36 is 6. The square root of y to the 10th, y to the 5th, and the square root of w to the 10th, w to the 5th. There's nothing left under the radical. That's just my answer. So number 15 there, if I multiply 3 times 18. What did you say?
54.
54, okay. 54, x to the
7.
x to the 6th, and u to the
6.
7th, right?
3.
That's the u's. On my x's I got 2 plus 4, and on my u's I have 4 plus 3. This one's not a perfect square, right? 54 is not a perfect square. I got to work with this one. 54 can be factored into. What number is your perfect square that divides into 54? 9 times 6, right? 9 is a perfect square. So 9 times 6 is the pair of factors you'd want to use for 54. We have an x to the 6th. We're leaving that one alone. We have a u to the 7th, however, that we need to fix.
Well, u times u to the 6.
U times u to the 6th. Now we can take out our square roots. What are we going to get? Square root of 9 is 3. Square root of x to the 6th is x to the 3rd. And u to the 3rd. Underneath our radical, 6 and a u. So we get 3x cubed, u cubed, square root of 6u. So depending where you're at on the review section, you may have to scroll down to get to the radical stuff if you would want to work on that right away. We've got one more homework page and we'll be done with all the topics in the review.